In this section, we're going to be talking about something called variables. Variables are a way for you to store information for use later, and they're a way for you to provide all sorts of different kinds of value storage and input that your programs will no doubt benefit from. So let's go ahead and get started with creating some. Once again, I'm going to go ahead and right-click and create a C# script. And I'm also going to call this test, just like before, with a capital T. And we'll double-click to launch monobehavior. And I'm going to go ahead and align all of my pairs of curly braces. Now, in our previous example, where we created our first script, we wrote our hello world statement right here. Now, instead of adding code to this, adding code to this script that belongs somewhere in a curly bracket, a set of curly braces that are associated with start or update, what I'm going to do is I'm going to go above those two. I'm still going to be adding code inside of a set of curly braces, but I'm going to be adding it above start and update within the test curly braces. So I'm just going to click right after this opening curly bracket and press the Enter key. Now, creating a variable is a multi-step process, and it really requires that you start to kind of understand some of the words that you're writing out. So what we're going to do is we're first going to go through this one, and we're just going to create a real quick variable, and then after the fact, we're going to go ahead and explore and just examine what it is that we just did. So I'm going to start off with the word public, followed by the word int, int. I'm going to type in my int. Be mindful that I used a lowercase m here and a capital I here. I'm going to use the equal sign, the number 0, followed by a semicolon. This is what declaring a variable looks like. We've just created a brand new variable. Now, while we don't yet understand the significance of it, we can still kind of dissect, kind of get an idea for what it is that we've just created. So let's start from the very beginning. This word right here, public, is something that we refer to as an accessor level. The accessor level is a word that describes how accessible something is. Now, there are 3 different kinds of accessor levels. For the start of this project, for the start of this program, we're mostly going to only concern ourselves with things that are public, which means that they're easily accessible. Anything can access this so long as it has visibility of it. And we don't exactly know what visibility means just yet, but suffice it to say that things that are public are more easy to access than other things. Next up is a very special word, and this word right here is it's a short abbreviated word, and we call this a data type. In particular, this data type is an integer. Now, an integer is a data type that is used to represent different kinds of numbers that are whole. So 1, 2, 12, -7. So long as the number doesn't have any decimal places, the integer is a proper data type for that kind of value. So let's say that you're making a game and you want it to store how much health the player has. You might want to store that using a variable that is an integer, that has a data type integer. Or let's say that you wanted to store the amount of ammunition, the number of items that the player has, or the size of their inventory, etc., etc. These are all candidates for the integer data type. Next up is you have the variable name. The variable name always starts with a lowercase letter and follows a notation that we refer to as camel case. Camel case is a notation in which every subsequent word that a name consists of is capitalized. So you can see here that my starts with a lowercase letter, but in order to follow camel case, every single subsequent word, for example, int, would need to start with a capital letter. So let's say I wanted to call this my super awesome integer. I would name it my super awesome integer. And you can see that every subsequent word starts with a capital letter, and that's kind of the rule behind camel casing. Now, variable names have a lot of other rules that are associated with them, but we'll talk about those in a video to come, not just right now. We're just going to get this, in this video we're just going to focus on creating variables. We're going to focus on data types, and we won't get into the nitty-gritty of how you of exactly what you should call your variables just yet. But I will say this: your variables should not include spaces, and your variables should not include numbers or any sorts of special characters. Right now, just make it so that they're all letters, and later on we'll describe some of the more specific, the more specific rules that are involved. I'm gonna go ahead and change this back to my int. So this second item right here is once again a data type, and there are several different data types that we're going to be creating variables for today. The first of which is an integer. The next thing is the name, like we've just kind of said. So I'll go ahead and notate that here. So the next thing is a name. So this is what you want to call your variable. If you were trying to store how much health a player has, you might call this health. If this was how much ammunition they had, you might call it ammunition. The name should make sense. For now, since it's just a demonstration, I'll call it my int. Next up, we have this equal sign. Now, in computer science, the equal sign is not the same thing as a normal equal sign from mathematics. In computer science, the equal sign is referred to as the assignment operator. There are lots of different operators, which again, we'll be discussing later on. But for now, suffice to say that the assignment operator does one thing. It takes whatever is on the right side and stores it or replaces it into whatever's on the left side. So in this example, the assignment operator exists here solely for the purpose of setting the value of whatever this is. In this case, it's my int. And then lastly, we have the value, which in this case is 0. So altogether, what we're doing is we're creating a new variable which has public accessibility. It is of type integer, which means it's capable of storing positive and negative whole numbers. We've chosen to call it myInt, and we have assigned it a starting value of 0. Now let's go ahead and save this. So I'm just going to click on File and Save. I'll go ahead and minimize this, and I'll create a cube just for the purpose of testing, because remember that you have to create a game object in order to be able to test out any of your scripts. I'm going to click on Add Components, Scripts, and we'll add our test script. And now I'll go ahead and press play, and nothing happens, right? The reason why nothing happens is we didn't write any code that actually makes something happen. Previously, when we wrote our print statement, we were telling the machine that we wanted it to print something to the screen, but we're not doing that here. What we're doing here is we've just set up this new attribute, this new variable. Now, one thing that you will notice is that in the inspector, underneath your test script, you now have this thing called myInt, and you'll notice that you can set this number to whatever you want it to be, which is kind of cool. So let's say that this was health, you might be able to you might want to set this value to 100. If it was ammunition, maybe you should set it to 12 or whatever makes sense for you. The point is that now it's capable of storing whole numbers, and its value is variable. You can change what that value is. Let's go ahead and take a look at some more examples of variables just to make sure that this concept is clear. Let's also explore some more data types. So let's go ahead and create another variable, which is going to start with the word public. The next variable data type that we're going to be looking at is the float. Now the float data type is capable of representing positive and negative numbers that contain decimal values. In other words, it's capable of storing data that basically resides in between numbers. So as your requirements become more and more precise, as you need to save information that is more and more specific, then using floating point numbers becomes much more important. If you're trying to save the speed of something, the very specific location of something, if you're ever just trying to get really exact, floating point numbers are a great place to turn. I'm going to name this variable myFloat. Now, the interesting thing about variables is you can pretty much name a variable whatever you want, but remember, there are rules, and we'll be describing what those rules are in greater detail later. So myFloat is just totally cool. We can call it whatever we want. I'm going to go ahead and set it equal to something, and the value I'm going to set it equal to is going to be 0.0, and for floating point numbers, you have to do something special. For floating point numbers, you have to put the letter F afterwards so that the machine knows that it needs to treat this like a floating point number. Now, you didn't have to put an I after this integer, and that's because Unity and C#, they automatically treat whole numbers as integers. Unity and C# does not treat decimal place numbers automatically as floating point numbers. It treats them as a different kind of data type. I don't want to go too much into the details of what kind of data type it treats it as. Suffice it to say, if you're ever using floating point numbers, just go ahead and throw that F afterwards, and if you forget to, don't worry, you'll end up with an error that will tell you that you forgot to include the F. In fact, I'll go ahead and do that now. So I'll go ahead and take away the F. I'll save this, and let's go ahead and see what Unity has to say about it. So this is the first this intentional error that we're encountering together. And if you go ahead and select it, just left click on it, it says, literal of type double cannot be implicitly converted to type float. Add suffix F to create a literal of this type. Now, that sounds like a whole bunch of jargon, and I know that can be really scary to read, but even despite all of this extra nonsensical stuff, you can still see that it is trying to tell you what you need to do to solve the problem. It says here, add suffix F to create a literal of this type. So it's reminding you that you forgot to include the letter F. So I just double click on this error. It'll take me to the line where the error is occurring, and I'll just go ahead and add my F. Okay, next up, I'll go ahead and type in public. Let's go ahead and make another variable. Oh, well, I guess it probably makes a lot of sense for us to go and test that out and make sure that it's working. So I'll go ahead and save. You'll see that clears up this error, so that goes away. And if I click on my cube, you can now see that I have a myFloat. And you'll see I can change my integer number to, an integer value. And my floats, I can actually change this to values that include decimal places. So that's the value of a float. You can store all sorts of very, very small numbers. Okay. So let's go ahead and take a look at different data types. So I'm going to go ahead and type in public, and let's go ahead and add a very simple data type. This is the bool. So I'm just going to call this myBool. Now, Boolean values are very simple because they can only be one of two values. They're either true or they're false. And we typically let's just go ahead and set this bool to false just to see what this looks like. I'll go ahead and click File and Save. And here you can see myBool, and it creates this handy little check mark here. And this either denotes that it is true or false. Let's go ahead and go back to our script. All right, the next value that I'm going to go ahead and insert, the next variable I'm going to create, is going to be of type string. Now, String is a data type that gets its name because it basically allows you to take a bunch of individual characters and string them together one after the other. I'm going to call this my string, and I'm going to set it equal to an empty set of quotation marks, which we'll just call an empty string. I'm going to go ahead and save this. And let's see what this looks like in the inspector. So you can see that by entering in, a string, that it gives you this blank void, and the reason why there's this blank text field is simply because we didn't type in any sort of like other value. See, we just have this empty string, but the stuff that you can store inside of a string is very, very versatile. You can store numbers in a string, but they're not treated numerically; they're treated symbolically. So what does that mean? Well, think about your address. Let's say that you live at like 12345 Super Duper Street. You can store all of that information inside of a string. Strings store characters, collections of characters. And so other examples of reasons why you might want to use a string can include things like your name. If I wanted to store my name, I could. If I wanted to store my screen name, I could also do that. There's all sorts of different applications for strings, but in short, strings are used to store collections of characters, and these collections of characters can be entirely symbolic. They're non-mathematical in nature. So without going too much further, let's apply this really, really quickly, and let's see how variables can be used to aid us. And we're going to do this in the most basic way possible, because I know that this single video is already covering quite a bit of information. There's a bunch of keywords that got thrown out there, and trying to keep these as bite-sized as possible. So let's try and do something in our code that is that really represents just how powerful these variables can be, and just kind of plants the seed for what we intend to do later on. So I'm going to return back to our first video that actually started to address scripting. I'm going to throw down a sprint keyword. So I'm just going to print keyword, and I'm going to want to print my string. So I'm just going to enter in the variable name there, and I'm going to go ahead and save this and minimize this. And so the idea with this script is that at start it's going to print whatever the value of my string is. So I'm going to go ahead and press play, and you can see that it prints out the string, but the string is currently empty, so there's nothing there. If I go back to the cube and I change this, so I say James. If I go ahead and press play, you can see that now it says James. And this is really powerful because now we're able to drive values that we enter into the inspector to do very meaningful things. And while this might not seem super meaningful, it will become very, very, very powerful later on. Now let me go ahead and show how you might be able to take this idea one step further. Let's say that you wanted to write a story that was driven entirely as variables. So let's say that I wanted to, here, let me just go ahead and get rid of all these values right here, all these variables. I'm just going to create a couple of new variables. I'll just create a public string, and I'll call this character name. And I'll say public string weapon, and I'll also set that to an empty string. And let's say I wanted to write out in my statement, I wanted to print out the character's name and weapon, and I wanted to do it in a meaningful way so that it sounded like, I was putting together a story. So let me just go ahead and type in character name, which will be replaced by whatever the value of this variable is. So I'm going to say character name. I'm going to use the plus sign because I'm actually going to sew a couple of strings together into a sentence. So I'm going to say character name plus, and then quotation mark. I'm going to add a space here so that it'll include a space in between the character name and what I'm trying to type here. I'm going to say has just equipped, and I'm going to do space, quotation mark, plus, and then I'm going to type in weapon. And the idea is that I want this value to be driven by a variable, and I want this value to be driven by a variable. And this kind of just like combines those two ideas together with some words that mean a lot to us English-speaking human beings. So I'm just going to go ahead and save that and minimize. And after Unity's had a chance to catch up, now you can see that I have a place where I can enter character name and I can enter weapon. So I'm going to go ahead and type in character name. So this will just be Finjitsu. Move my cursor out of the way. And the weapon I'm going to wield, let's say, is a katana. There we go. That's very apt. So I'll go ahead and press play. And you can see that it says Finjitsu has just equipped katana. And so that is just part of the power that you can get from variables. It allows for you to create placeholders for values, and those values can be modified at runtime. They can be modified in the inspector, and they can be used to drive functionality. This is, of course, just the very, very basic, most possible example of the process by which variables are created and how variables can be used. But hopefully you already kind of get an idea of just how powerful these ideas can be, and are hopefully getting some ideas on how you will be able to apply them to do all sorts of interesting things in the games that you plan to create. So quick recap. The keyword public is used anytime that you want to create something that you want to be very accessible, easily accessible. We talked about all sorts of different data types, ranging from integers, which store positive and negative whole numbers, floats, which store positive and negative decimal point numbers, floating point numbers, bools, which are capable of storing true or false values, and strings, which are collections of individual characters. We talked about individual variable names, and we said that these variable names are utilized just as placeholders, and that these variable names can follow certain naming conventions, but that we would talk more about what those naming conventions are in the future. We kind of really just said that we should always make sure that they start with a lowercase letter, always consist of nothing more than just alpha characters, just alphabetic characters, and should utilize camel case. And we also said that this equal sign isn't really the equal sign. We said it's the assignment operator. We said that whatever's on the right-hand side of an assignment operator gets stored in whatever's on the left-hand side of an assignment operator. And we also gave an example of how variables can be used in the very basic print statement that we learned from the previous video.